Welcome back, grade 8, to another math video. In this one, we're going to start taking a look at polygons. And actually, our polygons video, we're going to split into two different sections. So we're going to learn a little bit about polygons in this video, and then we're going to learn a little bit more about polygons, in particular, a little bit more about some of the exterior angles of polygons in another video. So first of all, the word polygon just refers to any closed-sided shape. So that could be a triangle, that could be a pentagon, that could be any shape that is completely closed in is called a polygon. And we're going to give some particular names to polygons, and we give names to polygons based on the amount of sides that they have. So, for example, any three-sided polygon we call a triangle. Three sides, and tri just refers to how many sides there are. Any four-sided shape, it doesn't have to be a square, it could be a rhombus, parallelogram, a trapezoid, anything like that, we call a quadrilateral. Refers to four sides. Quad means four. Any five-sided shape we call a pentagon. Again, penta means five. Quad means four. Any six-sided shape we call a hexagon. Any seven we call a heptagon, although we don't oftentimes talk about that. Eight we call an octagon. Just going to go over some of the more popular ones. We don't oftentimes talk about a nine-sided shape. 10 we call a decagon. And 12 we call a dodecagon. So that just refers to the amount of sides that it has. Now, obviously, we could have many other sided shapes. Generally, although there are some particular names for them, we usually just call them based on how many sides there are. So if there is a 20-sided shape, we might just call it a 20-sided polygon. Otherwise, though, these are some of the particular names that go along here. Because it has to be enclosed, the minimum amount of sides we can have is 3. Sometimes we also talk about a regular polygon. And the difference between a regular polygon and just a polygon in general is that a regular polygon has equal sides and angles. In other words, in a triangle, all the sides would be the same length and all the angles would be the same as well. So that would be a regular polygon. As opposed to just a general polygon as well. So that gives us a little bit of an idea of polygons. Now we're going to start talking about the sum of the interior angles of the polygons. And there's some formulas that we can use to go over that. We've already talked about triangles a lot. And we've talked about how in any triangle, the sum of the interior angles. Interior angles are just the ones that are inside, so that would be this one, and this one. The sum of the interior angles is always going to be equal to 180 degrees, no matter what. So we use that to figure that out. And depending on the size of the shape, or how many sides it has, there is a set sum of interior angles. So for any four-sided shape, it's going to have a sum of interior angles of 360 degrees. For any five-sided shape, it's going to have a sum of interior angles of 540 degrees. For a six-sided shape, it's going to have 720 degrees. And what's interesting about this is five-sided. And maybe you're starting to see this already, there is a bit of a pattern with this. And the pattern is that every time we add a side length, we add another 180 degrees to whatever our interior angles equal. And the reason for that is by adding another side length, we're actually adding another triangle. So if we take a look at a square, if I take a point here and I draw a line, I actually have two triangles. And two triangles, this would be 180, this would be 180, together they're 360. In a pentagon here, let's draw lines here and lines here, all the separation lines that we can have, we have three triangles, or 3 times 180 degrees. In a six-sided shape, if I were to draw lines, line here, line here, line here, I have 1, 2, 3, 4 triangles, or 4 times 180 degrees. So what's interesting is for our sides, 2 times 180 degrees, we can actually come up with a bit of a formula now to solve for the sum of interior angles for different polygons. So for an n-sided polygon, so n-sided just means that it has n amount of sides. That could be 5, that could be 105, however many that needs to be. Our formula for the sum of interior angles is going to be, now we started with a triangle. A triangle was our first one, so by the time we got to a four-sided one, we were already kind of in a little bit here. So we have 2 times for a four-sided, 3 times for a 5-sided, 4 times for a 6-sided. So it's always 2 less than the number of sides. So it's going to be n minus 2. So if we have a 105-sided polygon, it's going to be 105 minus 2 times 180 degrees. And that would figure out our sum of our interior angles. We're going to use that in some of our example and try it questions as we step through, as we solve some of these questions together. That's the end of our lesson part of it. If you'd like to stick around, we're going to be working through example 15, example 16, and example 17 together, which is going to help out with try it 15, 16, and 17. You can take a look at it on your own, or you can continue to take a look with it here together. Okay, let's start taking a look at some of these examples. First we have example 15. Example 15 gives us a shape, a polygon here, a four-sided shape. And it gives us some angle measurements. It says this is 55 degrees, this is 73, this is 115, and we're asked to figure out the missing side length here. Well, first things first is we need to figure out what's the total sum of interior angles for this shape. It's a four-sided shape, so this might be one that you know right off the bat, or we could use our method. A four-sided shape, I'm just going to tell you right now, is going to have a sum of interior angles of 360 degrees. So when we add all of these together, it has to equal 360 degrees. So in other words, 115 degrees plus 55 degrees plus 73 degrees plus x, don't know what that is yet, equals 360. When I add those other ones together, 115 plus 55 plus 73, I get 243 plus x equals 360. Just minus 243 from both sides. To figure out what's left, 360 minus 243 means that my missing angle must be 117 degrees. So that's how we would step through and figure that out using the information that we are given about that four-sided shape. Okay, example 16. Example 16. In this particular example, we are given a five-sided shape, and we are told that it is a regular pentagon. So if you don't quite remember, now I know I didn't draw it as a regular pentagon, but let's assume it is. If you don't quite remember, a regular pentagon means that all of the interior angles are going to be the same, and all the side lengths are going to be the same. We're also given a little bit of a triangle shape here, and we're asked to figure out this angle and this interior angle too. So let's start with x. So first of all, it is a five-sided shape, it's a pentagon. So to figure out the sum of interior angles, it's a five-sided shape minus 2 times 180. That's our formula for the sum of interior angles. So 3 times 180, which is 540 degrees. Okay, so that's the sum of all the interior angles. Because it's a regular polygon, or a regular pentagon, I have 5 angles here that are all the same. So to figure out x just equals 540 divided by 5. Or in this particular example, when I plug that into my calculator, I figure out that x has to be 108 degrees. Okay, now I have my first bit of information here. X is 108 degrees. Now I have to figure out y. Now y gets a little bit trickier. As I'm going through, I have to figure out, I basically have to figure out what is missing here. The way to figure out y will actually first be to figure out the missing sides beside it. So first of all, if I know that this is 108, let's treat this as a triangle here. I know that this is 108. I know that this and this are the same size, same length, which means that this angle and this angle have to be the same. So that triangle in total is 180 degrees, minus the 108 from x is going to leave us with 72 degrees. These two interior angles must be the same because these side lengths are the same length. So 72 degrees divided by 2 is going to leave me with 36 degrees for each of these. Okay, so this is 36 degrees, this is 36 degrees, but this triangle is actually the exact same. So this is 36 degrees, this is 36 degrees, and I know that this whole thing has to be 108. So 108 degrees minus 36 degrees minus another 36 degrees leaves me with y. And when I plug all those in together, interestingly enough, 108 minus 36 leaves me with 36 degrees left for my angle y at the top, that missing angle in between. So a number of different ways to go through to solve for what's there, but we're piecing together what we know in terms of triangles, regular shapes, in order to figure out our final value. Last example, example 17. Example 17 just says the angle sum of the interior angles of an n-sided polygon is 270. Find the value of n. So we're kind of working a little backwards here. We're given the interior angles already, the sum of them at least. We just need to figure out how many sides does this polygon have, does this shape have. So we're going to use our formula that the sum of interior angles equals n minus 2 times 180 degrees. We're going to use that formula, but we're going to have to rearrange it because we're solving for n this time, not for sum of interior angles. The sum of interior angles, we're already told, is 2,700 degrees, and that equals n minus 2 times 180. Let's start getting n by itself. First things first, let's get rid of this times 180. To do that, we divide both sides by 180 degrees. Those cancel out. 2,700 divided by 180 is 15. Now, I got rid of that, so sorry, that should be a minus. I got rid of this 180. I got rid of the brackets. So now I need to get n by itself. Our way of doing that is to get rid of this minus 2. The opposite of a minus 2 is to add 2 to both sides. 15 plus 2 is 17, which is our n, which means that this shape is a 17-sided shape. A 17-sided polygon would have a sum of interior angles of 2,700 degrees. Hopefully that helps. As you step through your try it 15, 16, and 17, feel free to look back at these example explanations for how to solve these particular questions.